Initially, TPM was total pre-maintenance. Then, TPM exceeded the total product maintenance and systematized by Japan. After that, the name changed from total product maintenance to total product management. Currently, TPM is a famous approach to TQM same world. In addition to this, in this book, I will explain the development of IoT Internet of Things and FA factory automation, as well as improving the skills of those involved in the field. This book introduces the practical actions of these activities. TPM is heavily involved in the equipment failure countermeasure process that GE, a US company, has been working on. In the past, equipment was considered to be something that would break down as it got older, and the countermeasure in the manufacturing industry was to carry out post-fault maintenance to restore equipment after it had broken down. However, in order to deal with the many production problems that came with breakdowns, GE took countermeasures by replacing parts before they broke down. However, this method was extremely costly. Therefore, improvements were made to parts and materials. This was the trigger for the process that evolved into activities to predict and improve equipment failures by making full use of various inspection equipment, and this process was named TPM in the industrial world, and its use spread. In Japan, TPM is taught by an organization called JIPM, which provides expert guidance. Since equipment failures cause a lot of waste in the manufacturing industry, the organization has presented 6 ways to eliminate waste and introduced effective countermeasures to each company. When Mr. Nakamura was working as a section manager at a Hitachi Metals Limited factory that produces special steel bars and wire rods, he needed to significantly speed up the TPM procedures in a workplace where 200 pieces of equipment were operated 24 hours a day by about 160 employees. The procedure he created is shown in the figure below. This is a countermeasure method based on the equipment failure zero countermeasure procedure based on the Eisen-Kojio method, which took 3 years to implement measures to achieve zero failures in large machines and was attracting attention from advanced Japanese companies at the time. The first step is forced deterioration, where dirt and dust cause equipment to break down in a short period of time, as shown in the figure. In order to ensure that everyone involved in the factory understands the effectiveness of this measure, Mr. Nakamura selected 4 pieces of equipment that had many subsequent breakdowns and were causing major disruptions to the factory's production and customer delivery dates, and each of the 4 section managers took command and set an example for themselves as they proceeded with cleaning and defect countermeasures together with the people involved. The model machine's failure reduction progressed quickly, and all the employees at the factory understood the effect of promoting TPM. Then, as everyone participated in implementing measures one after another, the effect became as shown in the graph. In addition, rags are needed to clean the equipment. So, we talked to the employees about this, and every household volunteered to provide a huge amount of rags, which greatly advanced the cleaning activity. In the past, the factory's maintenance department recorded the MTBF. In addition, the factory manager promoted the method of reporting the activity results to everyone in the previous diagram, but in this type of format, it was unclear what should be done on which equipment to get the greatest results, and how to quickly spread specific measures to similar equipment. As a result of the stakeholders' search for a solution, a visualization measure of the measures taken over a certain period of time, which is the inverse of the MTBF, was proposed, and the format of the diagram shown here was adopted. In essence, it was a method of displaying the records of measures taken against failures on a large sheet of paper. As a result, corrective maintenance became preventive maintenance, and corrective maintenance spread failure measures throughout the factory, and progress was great. From here on, I will get technical, so please refer to the book for details. but the equipment has a similar structure when broken down into parts. Therefore, with the help of knowledge and technical support from equipment specialists and specialist contractors, we proceeded with inexpensive equipment improvements that would not break down. As a result, the factory was able to bring 200 pieces of equipment to zero breakdown production in just 6 months. This method was 6 times faster than the TPM measures being implemented by other companies. In manufacturing sites, after reducing equipment failures to zero, measures are required to predict equipment failures. This response is the same as when humans undergo health checkups or take measures to prevent serious illness when they find small abnormalities in their daily lives. Therefore, Mr. Nakamura has been periodically showing this type of illustration under the name of equipment danger prediction measures, asking operators who manage the equipment to find abnormalities early, and has taken measures to have equipment experts find out whether there are any problems and learn about the structure of the equipment. In TPM, this measure is called developing people who are strong in equipment. This is a diagram showing the failure analysis that Mr. Nakamura did when developing personnel who are skilled in equipment failure. This failure led to the question of whether the cause of the failure was the electrical system or the structure of the mechanical equipment. Each expert said, "The cause of the failure is not within the scope of my expertise." So countermeasures continued to be slow to progress. At such a time, Mr. Nakamura organized an improvement team by grouping together people involved in the site. These people knew nothing about the equipment, but after analyzing this diagram, they discovered the problem: the limit switch has exceeded its lifespan. This was because the improvement team members had experience gaining from maintaining their own cars. This type of analysis is necessary for developing personnel who are skilled in equipment. The Amarub Iron Bridge on the Sanin Main Line, built in 1912, was made of steel and spanned a huge valley in the Sanin region. For 100 years after its construction, the bridge has supported the railway without any problems in the harsh natural environment of this area, thanks to the efforts of many maintenance workers. This maintenance know-how has been recorded, and in Japan, as many bridges and highways deteriorate, this has become a major national issue. The business development shown in the figure below has been effective. This development is one example that shows the value of the technology of maintenance. From zero equipment failures to comprehensive maintenance, maintenance management depends heavily on the abilities and activities of on-site managers. In essence, factory management is based on the principle of on-site management at the site, but in manufacturing sites where equipment plays an important role in production, early detection of abnormalities and taking measures with the cooperation of equipment specialists when small abnormalities are discovered are essential on-site management items. Not limited to equipment management, on-site managers, together with their subordinates, are responsible for increasing productivity and improvement at the manufacturing site. However, as shown in the figure, the management ability of this on-site manager can make a big difference in the occurrence of problems and the achievement of business budgets. In addition to measures to eliminate the difference in the capabilities of site managers, manufacturing companies need to improve the management capabilities of site managers to international standards, including the TPM and facility management introduced here. Therefore, this book provides detailed information on how to strengthen the 6 major capabilities, along with examples of their application, so please refer to it. Thank you very much for watching the introduction to this Kindle book. The above explanation is the gist of this picture book. You can also get it at this URL. Amazon Prime members can watch it for free.